Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0100, indicates a malfunction in the mass airflow, MAF, sensor circuit. This issue typically signals that the engine's powertrain control module, PCM, is not receiving appropriate voltage signals from the MAF sensor or the intake air temperature, IAT sensor. The MAF sensor plays a critical role in measuring the amount of air entering the engine, which is essential for optimal fuel injection and engine performance. The PCM relies on accurate readings from the MAF sensor to adjust fuel delivery, ignition timing, and other engine parameters. This specific DTC can lead to symptoms such as reduced engine performance, increased emissions, or engine stalling. The MAF sensor is generally located in the air intake pathway, close to the air filter, enabling precise monitoring of incoming air volume and temperature. The DTC P0100 specifies a malfunction within the MAF sensor circuit. This pertains to the electronic signals that connect the MAF sensor to the powertrain control module, PCM, which interprets these signals to maintain engine performance. The MAF sensor detects the volume of air entering the engine, while the IAT sensor measures the temperature of this air. Both sensors are typically integrated within the same connector, ensuring that the PCM can promptly analyze their readings. The PCM is usually located in the engine compartment near the firewall and is responsible for processing data from multiple sensors to optimize fuel mixture and ignition timing. When this DTC is set, it indicates that there is a disruption in the buttoned-up circuit, which could adversely affect engine operational efficiency and performance. Several factors can trigger DTC P0100. One primary cause could be a faulty MAF sensor, which may fail to produce accurate readings, causing the PCM to respond incorrectly to engine demands. Additionally, wiring issues such as frayed wires or bad insulation can lead to loss of signal or voltage in the MAF sensor circuit. Another potential cause is poor electrical connections at the sensor itself or the PCM. If there are loose terminals or corrosion present, this could interrupt the proper function of the sensor circuit. Furthermore, on rare occasions, the PCM itself may be malfunctioning, causing it to incorrectly interpret the signals from the MAF sensor or IAT sensor. Identifying these potential causes is crucial for effectively diagnosing and resolving the DTC. Symptoms associated with DTC P0100 include the illumination of the check engine light, which serves as the vehicle's alert system for malfunctions. Drivers may also experience poor acceleration as the engine management system struggles to adapt to inaccurate airflow data. Furthermore, rough idling can occur due to irregular fuel mixtures that affect engine operation. Increased emissions are another significant symptom of this DTC, as an inefficient engine not only decreases fuel economy, but also contributes to more pollutants being released into the atmosphere. These symptoms may vary in severity based on other underlying issues, but they collectively indicate that the engine is not receiving the accurate air measurement it needs for optimal performance. The initial step in troubleshooting DTC P0100 involves checking the status of the vehicle and clearing any stored codes using the Honda Diagnostic System, HDS. Begin by turning the vehicle to the on mode, ensuring all electronic components are operational without starting the engine. Once in this mode, use the HDS to clear the DTC. This process resets the system and allows you to assess whether the DTC has returned. After clearing the code, wait for at least 2 seconds to stabilize the system, and then recheck for any pending or confirmed DTCs using the HDS again. If P0100 reappears, it indicates an ongoing issue requiring further investigation. Step 2 involves checking the voltage supply to the MAF sensor/IAT sensor. Start by turning the vehicle off completely to prevent any electrical shorts. Next, disconnect the MAF sensor or IAT sensor 1 by removing its 4-pin connector. With the connector removed, turn the vehicle back to the on mode without starting the engine. Using a multimeter, measure the voltage between specific test points on the connector. Test point 1 corresponds to the female terminal number 2, and test point 2 corresponds to female terminal number 3 of the MAF IAT sensor connector. You're looking for an approximate voltage of 5.0 volts, which indicates that the sensor is receiving proper power for operation. If the voltage is confirmed, proceed to the next step. If not, further diagnostics into the wiring and connections should be conducted. In this step, the focus shifts to examining the VCC2 wire for any potential shorts. Begin by turning the vehicle off to ensure safety during diagnostics. Use the HDS to jump the SCS line, which stands for SRS control circuit, and wait for more than 1 minute to reset. After this, disconnect the PCM connector E, commonly recognized as an 80-pin connector that interfaces with various sensors, including the MAF sensor. At this point, check for continuity between the test points, the MAF sensor's terminal number 3, and the body ground. If continuity is present, it indicates a short in the VCC2 wire, requiring repairs to restore functionality. On the other hand, if there's no continuity, the wire is not shorted, leading you to the next step. Step 4 entails checking for any open circuits in the VCC2 line. Confirm that the vehicle is still in the off position and that the MAF IAT sensor connector remains disconnected from the harness. Similar to the previous step, again use your multimeter to measure the continuity between the MAF sensor's female terminal number 3 and the corresponding wire on the PCM connector E, specifically pin number 77. If continuity is proven, this means the VCC2 wire is intact and functioning as it should, allowing you to proceed to subsequent checks. However, if there is no continuity, it indicates an open circuit in the VCC2 line, necessitating repairs to restore connectivity between the MAF sensor and the PCM. The fifth step focuses on assessing the SG2 line for continuity. Once again, ensure the vehicle is in the off mode and confirm that the MAF IAT sensor connector as well as the PCM connector are disconnected. This time, measure the continuity between the MAF sensor's female terminal number 2 and the corresponding pin on the PCM connector E, specifically pin number 78. If continuity exists, it confirms that the SG2 wire is functioning correctly, allowing you to explore any additional service bulletins or known issues that may relate to this DTC or symptom. However, if no continuity is found, there is an open circuit that must be located and repaired to restore proper signaling in the circuit. Step 6 involves evaluating the FGP line for shorts. First, turn the vehicle off completely. Utilize the HDS to jump the SCS line, allowing for a reset period of over 1 minute. After that, disconnect the PCM connector E for testing continuity. Measure the continuity from the MAF sensor's female terminal number 1 to the body ground. If continuity is verified, it indicates a short exists within the FGP wire between the PCM and the MAF sensor/IAT sensor, necessitating immediate repairs. However, if no continuity is detected, this suggests that the FGP wire is not shorted to ground, allowing you to proceed to the next step in the troubleshooting process. The seventh troubleshooting step consists of checking the FGP line for any open circuits. As always, confirm that the vehicle is turned off and both the MAF IAT sensor connector and the PCM connector are disconnected. Use the multimeter to verify continuity between the MAF sensor's female terminal number 1 and pin number 61 on the PCM connector E. If continuity is confirmed, it means the FGP wire is intact, enabling you to move on to more advanced checks. Conversely, if there is no continuity, this indicates an open circuit in the FGP line that requires immediate repairs to ensure healthy communication between the MAF sensor and the PCM. In Step 8, the status of the FGP line is further scrutinized for potential shorts to power. Start by switching the vehicle to the on position without starting the engine. With the connectors still disconnected, measure the voltage from the MAF sensor's female terminal number 1 to the body ground. If any voltage is detected, this suggests there is a short to power in the FGP wire, requiring repairs. However, if no voltage is present, it means the FGP wire is functioning correctly and stabilizing the inputs to the PCM. Ensuring the integrity of these wires is critical to prevent future occurrences of code P0100. Step 9 focuses on the final check of the MAF sensor IAT sensor. With the vehicle turned off, proceed by substituting in a known good MAF sensor IAT sensor that has been verified to function properly. After installation, reattach all previously disconnected connectors to ensure a complete circuit. Utilize the HDS to exit the SCS mode before turning the vehicle back on. Once the vehicle is in the on position, clear any existing DTCs using the HDS. Wait for approximately 2 seconds or more, and then scan for pending or confirmed DTCs once more to verify whether the issue has been resolved. If DTC P0100 is no longer indicated, the sensor was likely the source of the problem. If it persists, further investigation into the PCM may be needed. The final repair verification step is crucial to ensure that the diagnostic and repair process was effective. Commence by rechecking all diagnostic results to confirm the resolution of code P0100. This involves running another scan with the HDS to ensure that no further DTCs are present. Following this, a comprehensive test drive should be conducted to assess the restoration of vehicle performance and to observe for any unusual behaviors, such as stalling or loss of power. Additionally, keep an eye on the fuel economy and smoothness of acceleration as other indicators of repair success. When the vehicle operates without issues and returns to optimal performance, you can finalize the repair process. Preventive maintenance serves as an effective approach to mitigate future occurrences of DTC P0100 and similar issues in the Honda CR-V. Regular inspections of the MAF sensor are essential. Clean the sensor periodically to ensure accurate readings and performance. Inspect electrical wiring associated with the MAF sensor for any signs of wear or damage. Ensuring that all connections are secure and free of corrosion will also extend the lifespan of the sensor circuit. It is advisable to use quality OEM replacement parts to ensure compatibility and reliability in repairs. Being proactive in maintenance could greatly enhance the longevity and performance of the vehicle. In conclusion, DTC P0100 signifies a malfunction in the MAF sensor circuit, impacting engine performance and efficiency. Troubleshooting requires a systematic approach, involving a series of checks that range from electrical testing to component substitution. Successfully addressing this issue not only eliminates the DTC, but also restores optimal vehicle performance, characterized by smoother operation, better fuel efficiency, and reduced emissions. Future challenges can be minimized through preventive maintenance practices, including regular checks on the MAF sensor and associated circuitry. Being vigilant regarding these elements ensures a reliable driving experience and prolongs the life of the engine components. Please like and subscribe to the channel. See you next time.